Ladies and gentlemen, next agenda is singing our national anthem, Indonesia Raya. Ladies and gentlemen, please stand up. Ladies and gentlemen, please sit down.
Ladies and gentlemen, we are now going to listen to the opening speech delivered by the chairman of International Conference on Agricultural Self-Sustainability 2022. Ladies and gentlemen, please welcome Insinyur Didik Wisnu Wijayanto, Master of Science Bioresearch, PhD.
Good morning, ladies and gentlemen. First of all, allow me to introduce myself. I am Didik Wisnu Wijayanto, the Chief Executive of the ICHAS 2022. Welcome and thank you very much for your participation in the International Conference on Agricultural Sustainability ICHAS 2022. The Honorable Rector of Diponegoro University Semarang, Profesor Dr. Yos Johan Utama Esa, M.Hum. Selamat pagi, Bapak Rektor. The Dean of the Faculty of Animal and Agricultural Science, Diponegoro University Semarang, Profesor Dr. Insinyur Bambang Waluyo Hadi Eko Prasetyono, MS, MAGR, Ibu. Selamat pagi, Bapak Dekan. Speakers, Profesor Dr. Florentina Kusmiati from Diponegoro University. Selamat pagi, Profesor Kusmiati. Profesor Hideto Ueno, PhD from Ehime University. Ohayo gozaimasu, Sensei. Profesor Peter Jebet, PhD from Curtin University, Australia. Good morning, Professor Peter. Associate Professor Toshihiro Kono, PhD from University of the Ryukyu, Japan. Ohayo gozaimasu, Professor Kono. Associate Professor La Chu Chou, PhD from National Chiai University, Taiwan. Choang, Laosa. Distinguished participant of ICHAS 2022. Welcome to the International ICHAS 2022 program, hosted by the Faculty of Animal and Agricultural Science, Diponegoro University, Semarang. Currently, there are 200 presenters and participants from several countries: Indonesia, India, Pakistan, Malaysia, and Russia, joining this event. The COVID-19 affect both farm and the global community. Hence, it is important to work to engage with many stakeholders to strengthen agricultural sustainability, especially during the post-pandemic. This conference internationally engaged with the concept of strengthening agricultural sustainability, as it is the dominant discourse to define, measure, and develop solutions to the hunger problem. We hope that the result from this conference may form the basis for the decision that policymakers and other stakeholders need to consider to improve agricultural sustainability in the global world system. Thanks to the organizing committee who have worked hard so that the ITAS 2022 may be taken place today as scheduled. This conference cannot be separated from the solid cooperation of the committee, participants, and speakers, as well as valuable suggestions from the steering committee. Indeed, everything is inseparable from shortcoming, and therefore we apologize if in the preparation and implementation of ITAS 2022, there are still many shortcomings that cannot be avoided. On behalf of the committee, we apologize profusely. Finally, congratulations on participating in the ITAS 2022 from the beginning to the end. If you have a not good experience in an ITAS 2022, please let us know. And if vice versa, please tell your colleagues so that they may also participate in the next ITAS activity. Once again, thank you very much for the participation and cooperation. Warm greeting to all of you from us here, the Faculty of Animal and Agricultural Science, Diponegoro University, Semarang, Indonesia. Thank you very much indeed.
Thank you, Insinyur Didik Wisnu Wijayanto, Master of Science Bioresearch PhD, for the opening speech.
Ladies and gentlemen, we are now going to listen to the opening speech delivered by the Dean Faculty of Animal and Agricultural Sciences, Profesor Dr. Insinyur Bambang Walio Hadi Eko Prasetyono, MS MAger IPU.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen, fellow speaker, and all of the audience joining us online from around the world. We are welcoming you in the International Conference on Agriculture Sustainability, ICAS 2022. And thank you very much for your participation in this event. First, thanks to the Honorable Rector of Universitas Diponegoro Semarang, Professor Dr. Yosjon Utama, SH.M.Hum, who always support us. Second, may I thank each of our speakers for taking part in this event. The quality and caliber of speakers in this year is outstanding. First, Professor Florentina Kusmiati from Diponegoro University, Indonesia. 2, Professor Hideto Ueno from Ehime University, Japan. 3, Professor Peter J. Batts from Curtin University, Australia. 4, Associate Professor Toshihiro Kono from University of the Ryukyu, Japan. 5, Associate Professor Lan Yizu Cho from National Chiayi University, Taiwan. It is my great pleasure to welcome you to the Universitas Diponegoro, Faculty of Animal and Agriculture Sciences, Universitas Penegoro, is the reputable faculty in Indonesia and in the world. Faculty of Animal and Agriculture Sciences has 7 study programs, starting from Bachelor of Animal Science, Bachelor of Agroecotechnology, Bachelor of Food Technology, Bachelor of Agribusiness, Master of Agribusiness, Master of Animal Science, and Doctor of Animal Science. The 3 study program at Faculty of Animal and Agriculture Sciences have also received international accreditation. Based on the QS World University rankings, our faculty managed to rank 400 plus in the world in the field of agriculture. Even the QS graduates employability rankings put Universitas Penegoro in first place. This year, we are holding our major annual event as we come together today with the theme of strengthening agriculture sustainability and technology post-COVID-19. We know that COVID-19 occurs some problem and affect all the human life. Agriculture sector also got the impacts. Farmer must adapt with the new environment. With virtual ICAS 2022 program, we hope this conference may form the basis for the decisions that policymakers and other stakeholders and other stakeholders need to consider to improve agriculture's sustainability. We are truly grateful for this. So by coming here, you are helping us to build and develop research to strengthening agriculture's sustainability. This conference aims to foster understanding and dialogue among researchers, and we hope that the result from this conference can give the best contribution. I wish all of can discuss and exchange of knowledge about what happened today in agriculture sector after pandemic happens. Last but not least,
Ladies and gentlemen, we beg your pardon for the technical difficulties. Let us wait for a couple of minutes, return normal session. Thank you for your patience.
Please accept our sincerest apologies should there be inconveniences that occur before, during, or after the event. With these words, I declare the International Conference on Agricultural Sustainability ICAS 2022 opens. May God bless us all with a good health to make this event a successful and enjoyable one. I do hope you will enjoy the conference, and you should know one thing for sure: you are welcome today and you are welcome back. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Ladies and gentlemen, we beg your pardon for the inconvenience that has occurred. We very thank you for your sincere patience. Now let's move on to the main agenda. Thank you Profesor Dr. Insinyur Bambang Walyo Hadi Eko Prasetyono, MSM AGR IPU, for the opening speech. Ladies and gentlemen, before we proceed to the main agenda, let us take some pictures to commemorate this day. For all participants, please turn on your camera. Ready? 1, 2, 3. Into the next slide. Ready? 1, 2, 3. Into the last slide. Ready? 1, 2, 3. Thank you for your sincerity.
Ladies and gentlemen, now we come to our main program, which will be led by our moderator, Insinyur Karno, Master of Applied Science, PhD. First of all, allow me to introduce our moderator. He was a former head of Agroecotechnology program. He finished his bachelor degree at Universitas 11 Maret and master degree at Massey University at Palmerston North and doctoral degree from the University of Queensland. And expertise plant physiology. To Insinyur Karno, Master of Applied Science, PhD, time is yours.
Okay, ladies and gentlemen, all participants of this seminar, good morning, all of you. Assalamualaikum warahmatullahi wabarakatuh. In this plenary session, I will act as a moderator, and I would like to introduce myself first. I'm Karno from study program of Agroecotechnology, Diponegoro University. In this first plenary session, we will have two invited speakers. The first is Professor Kusmiati from Diponegoro University, and the second is Professor Hideto Ueno from Ehime University, Japan. We will have two speeches, and each speaker will have 25 minutes to give a presentation. So let's start with the first invited speaker, Professor Kusmiati. Please display the CV.
Okay, thank you, moderator.
So the first invited speaker is Profesor Dr. Insinyur Florentina Kusmiati. is from Laboratory of Physiology and Plant Breeding, Department of Agriculture, Agro-Technology Study Program, Faculty of Animal and Agricultural Sciences, Diponegoro University, Indonesia. His interest is plant science and plant breeding. Her speech with the title Increasing Agriculture Production in Marginal Land, Crop Improvement Approach, with a live presentation. So, good morning, Prof. Kusmiati.
Morning, Pak Karno. Good morning, Pak Karno. Oh, sudah.
Okay. So, if you ready, you can have the first presentation with the title Increasing Agriculture Production in Marginal Land, Crop Improvement Approach for 25 minutes. So, Prof. Kusmiati, the screen and the time is yours. Please.
Okay, thank you, Pak Karno, as a moderator. I will try to share my PPT first. Okay. Yeah, okay. I think there is something wrong with my connection, because I'm not a co-host in this meeting, so I cannot share my screen. Wait for a minute. Please, committee, can you help me to can you help me to change my task as a co-host, because I cannot share my PPT.
Belum bisa share.
Yeah, I'm sorry. Okay. Okay, wait for a minute. Or maybe a committee, Mas Agam, can you help me to share my PPT? PPT-nya di sini. Sudah kelihatan. Udah. Okay. Thank you for the committee. Okay. Good morning, ladies and gentlemen, the Honorable Rector of Universitas Diponegoro, Dean of Animal and Agricultural Sciences, keynote speaker, presenter, and participant of International Conference of Agricultural Sustainability 2022. Okay, today, this morning, it's very honorable that I be a keynote speaker at the first session. Okay, I will present my paper with the title Increasing Agriculture Production in Marginal Land, Crop Improvement Approach. As we know that as we know that productive land. Okay, I'm sorry. Sebelumnya. Oh, gimana? Nyanyi itu. Gitu. Sebelumnya Okay, I'm sorry, there is something wrong with my device. Okay, productive land can be degraded to unproductive land. Land degradation is a global problem largely related to agricultural use. Climate change is one of the causes of land degradation. Over the period of 1961 to 2013, the annual area of dry land in Drag has increased, on average by slightly more than 1% per year. Productive land will be degraded to marginal land before it becomes unproductive land. Marginal land can be defined as a land with a low quality because of the many limiting factors for agriculture. Land may be marginal for a number of reasons, including poor water supply, poor soil quality, pollution from previous industrial activity, and so many. In Indonesia, marginal land is reported around 156 million hectares that consists of acetic soil is around 104 million hectares, and then saline soil is around 13 million hectares, and peat soil is around 20 million hectares. First, we will discuss about what is acetic soil. Soil acidity is a condition in which the soil pH is lower than a natural pH or less than 7. The criteria of acidic soil such as have a pH of less than 5.5 in both dry and wet soil. Also, it is usually type of soil is oxisol, ultisol, and inceptisol. The acidic soil have a very low soil organic matter content, soil cation exchange capacity is low, and also the ability of macro and micronutrient is low. The figure 1 shows that the range in a pH normally found in soil under native and or natural condition. pH value below 7 indicated greater soil acidity as value become lower. And then what is a saline soil? Actually, soil salinity is not only problem in soil, but it's a water problem. Excessive level of soluble salt in the soil water will limit the ability of plant root to absorb the water. We can see in the figure 2, there are two pictures that show the excess with soluble salts causing drug-like symptom in plant. For figure 2a, it shows that when plant grow at non-saline soil solution, plant root will able to absorb soil water, so plant will grow well. But if plant grow at the saline soil solution, the ability of plant root will limited to absorb soil water, then causing a drug-like symptom in plant. Saline soil are usually categorized in the 3 types: saline, sodic, and alkaline sodic soil. But based on the classification of soil, based on the electrical conductivity, saline soil can be classed as non-saline soil, slightly saline soil, moderately saline soil, very saline soil, and extremely saline soil. Okay, this is a figure that some effects triggered by salt stress on plant. Actually, salt stress will cause oxidative stress, osmotic stress that will affect physiology damage such as oxidative unbalance, protein degradation, and then cell membrane damage. Both three of these factors will cause growth and development plant affected. And then stress actually not only due to abiotic but also because of biotic factor. Stress is an external condition that adversely affect growth, development, and production of plant. Environmental stresses such as because of salinity and then nutrition, heavy metal toxic, or because of other factors such as temperature, and then also biotic factors such as insect and pathogen. And then figure 4 show that plant respond cascade to different abiotic stress. If plant face a drought and salinity, flooding, or heavy metal toxicity, plant will give a response or a stress response mechanism and plant, such as physiology, transcription control, and additional effect. That all of these factors will reduce the yield or yield loss. Actually, there are plant response under environmental stress. We can divide it into four. The first one is avoidance, when plant prevent exposure to the stress. And then second is tolerance, that permit the plant to withstand stress amid the existing stress factor. And then resistant when incompatibility between host and pathogen, and also acclimatization, that's alter physiological mechanism to respond to the stress. In this paper, I choose 3 strategies for increasing agriculture production in marginal land. So I choose plant tolerant, and then we can use cultural technique, and then the last is using plant breeding. There are 3 strategies for increasing agriculture production in marginal land. They are plant tolerant, using cultural technique, and also plant breeding. I will discuss one by one. Okay. For a tolerant plant, we already evaluate 10. We already evaluate 10 forage crop. Five of them are legume, and then the next 5 is forage grass. Then we calculated the cumulative degree of tolerance index. This cumulative degree of tolerance index is to determine the tolerance cumulative. That is a combination of several observed characters, which the value of each heredity as weighted. The tolerance criteria based on the cumulative degree of tolerance index can be classified or divided into 5 classes. If the CDTI is more than 4.5, this plant classified is very tolerant at saline soil. But if the CDTI around 3.5 to 4.49 is classified as tolerant. If the CDTI around 2.5 until 3.49 is moderately tolerant at saline soil. If the CDTI around 1.5 to 2.49 is sensitive, but if the value is less than 1.5, is classified as a very sensitive plant at saline soil. The result that from my research show that from 10 forage crop tested, only Sesbandia grandiflora that classified as moderately tolerant at saline soil. Among the 5 forage grass, Panicum maximum had the highest tolerant index. And then from this research, I continue this research, try to plant those two plants at saline soil in the Rembang Regency. The electrical conductivity or EC at Rembang Regency is around 3.8 decisiemens per meter during rainy season and 4.1 decisiemens per meter during the dry season. The objective of this field experiment was to evaluate the effect of manure at saline soil on forage production, quality, and livestock carrying capacity of Panicum maximum and Sesbandia grandiflora. And in this research, forage crops were planted both at monoculture and mixed cropping. And then we also use rice straw as a mulch. The treatment were different doses of manure as organic amendment that consists of 0, 10, and 20 tons per hectare. We calculate land equivalent ratio that can be shown at figure 6. Forage production of Panicum maximum and Sesbandia grandiflora at monoculture was greater than at mixed cropping in the same doses of manure. However, land use efficiency that calculated as a land equivalent ratio was greater than 1 in all of manure treatment. The greatest land equivalent ratio was achieved at mixed cropping of Panicum maximum and Sesbandia grandiflora with 20 tons per hectare manure. This indicated that 80% more land will be needed in monoculture to yield the equal amount of dry matter production in mixed cropping. Land equivalent ratio at treatment at no manure and 10 ton per hectare manure were 1.4 and 1.6 respectively. It suggests that mixed cropping between Panicum maximum and Sesbandia grandiflora at moderately saline soil use nutrient, water, and air better than planted solely, and competition between those two plants is minimized. And then from those research, we also calculated the carrying capacity at doses of manure 20 ton per hectare mixed cropping between Panicum maximum and Sesbandia grandiflora. The carrying capacity is 10.8 animal unit per hectare per year. It's higher than the other treatment is 10 ton per hectare of manure or 0 ton per hectare of manure. This carrying capacity is based on dry matter production. We also calculated carrying capacity based on crude protein. The result also showed the same trend that 20 ton per hectare manure at mixed cropping Panicum maximum and Sesbandia grandiflora can accommodate around 13.6 animal unit per hectare per tahun. It's higher than the other treatment. And then those forage crop were fed to the goat, and we have 3 treatment. If we see the live weight gain, we can see that if Panicum maximum and Sesbandia grandiflora with a proportion fat is 60 and 40%, the live weight gain is higher than Panicum maximum compare other treatment. And then we also evaluate the carcass of the goat. This is the appearance of the body of goat being fed from forage plant in saline soil. And then the third strategy that I want to suggest is about a crop breeding approach. There are at least 3 methods of plant genetic modification such as the first is hybridization, and then mutation, and then genetic and engineering. This is three methods of genetic modification that I have done for research. Plant breeding can be associated with cooking that require 5 important factors. The first factor is science and technology. Now we already know that there are many technology in plant breeding, such as gene editing, CRISPR. Both of those new techniques are being used to breed plant with desired trait and have the advantage of being more precise and faster to apply than other plant breeding technology. The second important factor is plant breeder or human resources. Plant breeder try to improve the economic value and user acceptability of plant species. For this work, the plant breeder need, in addition to thorough knowledge of plant genetics, and also working knowledge in other scientific disciplines such as agronomy, plant pathology, statistics, and other. And then the third is about the third of important factor is raw material. In this case, in this plant breeding, is genetic resources. Genetic resources can be defined as all material that are available for improvement of cultivated plant species. In classical plant breeding, genetic resources might also be considered as those material that without selection for adaptation to the target environment do not have any immediate use for the breeder. According to the extended gene pool concept, genetic resources might be divided into primary gene pool, secondary gene pool, tertiary gene pool, and isolated gene. And then the third important factor is equipment to do activity, such as facility of the laboratorium, also a fund for doing research. And then the third is seed production and marketing. This is the last important factor in crop breeding approach. Our research already try to breed our soybean that tolerant at arid land or at dry land. We make a hybridization between Dering variety and Grobogan variety. As we know that Dering variety is resistant to dry land, but it has a small seed. And then Grobogan variety is not sensitive to arid land or dry land, but it has a big size. So we make a hybridization between both of those variety. At first filial or at F1, we see that if we make a hybridization between Grobogan and Dering, the weight of 1000 seed is higher. Then also those progeny has resistant to arid land. Okay, and then another project that we have done, although it's not related to marginal land, is about breeding of yard long bean for high antioxidant content and sweet taste. And for this yard long bean breeding, we make a hybridization between purple pot and then green pot. And then selection method was done at a character of sweetness level, anthocyanin content, and agronomy trait. Those character was evaluated for each generation. And then at the final generation, we evaluate those progeny between plant stand. We can see at figure 1 that yard-long bean genotype was planted between a stand of Thymocarpus longan and Pisidium guajava stand. And then this is the stage of our work. As I mentioned before, that we make a hybridization between purple pot and green pot, and then we do a selection based on the sum of characters such as sweetness and then other agronomic character. And then for multi-location testing, we do at many locations at lowland and midland that conducted in Tembalang Regency, and also we do research for multi-location is in highland that done at Sumawono, and then as we mentioned before that we also done those research at underplant stand that located in Agro Technopark Undip. From those breeding, yet long been breeding, at least we have 5 genotypes that has a special trait. The first genotype is purple pot that high sweetness level, and then the second genotype also have the same trait with the first genotype that is has purple pot and high sweetness level. And then the third is the new candidate of new variety, I hope, that has early flowering and putative setting condition. And then the other that is special is the fifth genotype that has a trait of early flowering and high yield potential. This is the work for plant breeding in yard long bean. And then the next method of genetic engineering is a mutation. We have done a mutation of soybean seed. This soybean seed was induced mutation by gamma ray. And then we done selection those soybean seed or mutant soybean seed at saline soil in Rembang Regency that has electrical conductivity is around 4 decisiemens per meter, and we can see in this picture that at early growth of soybean,
The time is
there
up.
are decrease. Yeah.
Would you like to speed up the speech?
Okay. Okay. Soybean was induced mutation by gamma ray at different state, and then selection was done at a saline soil at Rembang Regency. Increasing dosing of gamma ray radiation will reduce early growth of soybean. And then we also evaluated the genetic diversity of soybean mutant at saline soil based on RAPD marker. We use 6 markers, and it showed that there is genetic diversity of soybean mutant at saline soil. And then we also evaluate that there is a morphology diversity of soybean mutant such as leaf shape leaf and flower color. The other mutation that we have done is mutation is at ornamental plant, Calistapus sinensis. Those ornamental plant induce mutation by gamma ray and at different doses, and then we do selection at lowland and highland. We can see there is a diversity of plant height of some of the mutant of those ornamental plant. Some mutants show plant height is higher than the control, but other mutants show a dwarf plant. And then from this mutation, we see also the diversity of flower. Main stack length of flower of Calistapus sinensis mutant is longer than a control flower. Also, there are 2 genotypes that had many flowers compared to the control. Also, there are a different color of the flower. At least there are two genotype that has different color compared with the control parent. Okay, this is the last that I want to talk is about genetic engineering or transgenic plant. Transgenic plant are the one whose DNA is modified using genetic engineering technique. The aim is to introduce a new trait to the plant which does not occur naturally in species. Transgenic plant contain a gene that have artificially inserted. The inserted gene sequence is known as a transgene. It might come from an unrelated plant or from a completely different species. The purpose of inserting combination of gene in plant is to make it as useful or and productive as possible. I just want to show some of the plant that tolerant to the acidic soil that is harindong or Melastoma malabatricum. This plant is highly tolerant of low pH or at pH 3 and high aluminum, and also aluminum hyperaccumulator. This is a model and source of plant tolerant gene to aluminum at acidic soil. And then the last is about source of drug and salinity tolerant can be from these four plants such as Distillitis spicata, Portulaca, and Spinifex, and also Rhizospora. I think this is all that I want to share about my research or my talk. And then now I would like to thank for your time and attention today, and I give back to the moderator. Thank you, Pak Karno.
Okay, thank you for Prof. Kosmiati for the interesting speech. Now we will have the second invited speakers, Prof. Hideto Ueno from Ehime University, Japan. I would like to greet Prof. Hideto Ueno. Good morning, Prof. Hideto Ueno. Are you here? Good morning.
Yeah.
Okay, Prof. Hideto Ueno is here and is from Laboratory of Soil Science and Plant Nutrition, Department of Agrobiological Science, Graduate School of Agriculture, Ehime University, Japan. And his research interest is soil science, organic farming, nutrient management, and soil chemistry. And Prof. Hideto Ueno will give the video presentation with the title Development of Local Sustainable Crop Cultivation Technology Using Unused Organic Resources and Leguminous Manure. So, would you start the video?
Yeah. Would you start my video?
Hello, I'm Hideto Ueno, a soil scientist, a professor at Ehime University, Japan. Thank you for the invitation to speak about my research results. I'm grateful for the opportunity to speak to such a wonderful group of professionals. I have been studying on sustainable agriculture techniques for 37 years, such as nutrient management, waste utilization, weeding, and environmental conservation. Of course, higher yield and quality are the main goal. You are probably aware that the population of the planet is growing rapidly. The population is increasing by 1 billion people per decade. This figure shows the world population, which was released in 2006, and is increasing as expected and reach 8 billion by November of this year. This is also to be expected, but as the population grows, so does the need for food, and countermeasures are needed. The most important thing in food production is fertile soil. I think two factors underlie the ability of the earth to support the enormous increase in number of people now living. The first, the resilience of soil in response to increasing demands made on them. The second, the increasing knowledge of farmers and scientists about how to manage soil's productivity and sustainability. Agriculture engineers and researchers have developed various technologies to increase yield. For example, chemical fertilizers, chemical pesticides, agriculture machinery, breeding of high-yield varieties, and field preparation. This has led to year after year increases in yield. This figure shows average wheat yields in the United Kingdom, which have increased rapidly since 1950, but stopped increasing after 1987. The Rotham State Institute is the most famous agriculture experiment station in the world and has the highest level of agricultural technology, but the yields are still capped. The situation in other regions of the world is similar. The upper limit has been reached. Okay, we'd like to take a look at the state of agricultural land around the world. This map shows soil degradation area. The red areas are highly degraded. The yellow areas are normally degraded. The white areas are stable with no soil degradation, and the gray areas are desert areas without vegetation. Most of these areas are thus undergoing soil degradation and have reduced soil fertility. Many attempts to introduce continuous arable cropping systems into the semi-arid, semi-humid, and humid tropics have failed, unfortunately. Often, the maintenance of the nutritional status of the soil has not been adequate. Other causes of failure include soil degradation in one or more of the following ways: physical degradation due to erosion, compaction, and crusting; chemical degradation associated with nutrient mining and acidification; biological degradation associated with loss of organic matter; deterioration of drainage conditions causing waterlogging or salinization. This picture was taken in Ethiopia. You can see people carrying firewood. This used to be a lush green forest. However, due to repeated grazing and logging, the vegetation has disappeared and the land has become desert. This kind of desertification phenomenon is occurring in many parts of the world. This picture was taken in a Japanese vegetable field. Rains and winds remove fertile topsoil away from farm fields. Soil is a precious resource because, on average, soil generates at a rate of only 0.05 millimeter per year. However, the loss of fertile soil is about 2 millimeters per year depth in the world. This is a video of gully erosion that occurs on farmland in the United States. fertile soil has been washed away, leaving only hard bedrock. Farming is not allowed here. Soil erosion often occurs on slopes like this. In the United States, 60 million tons of soil were lost in 1977 alone. This video shows wind erosion that occurred in the United States in 1935. It was also called Dust Bowl. Soil conservation laws have been enacted, and the occurrence has decreased, but large wind erosion still occur occasionally. The most soil degradation is occurring, unfortunately, in Asia, followed by Africa, America, Europe, and Oceania. The next problem is soil pollution with agrochemicals. This chart compares pesticide use around the world. Japan is one of the countries in the world that uses the highest amount of pesticides. Why is this? I have an idea. This is a picture of oranges. I took a picture at a supermarket in the United States. They are bruised and show a little pest damage. On the right is Japanese oranges. They look very beautiful compared with those in
Berhenti. Layarnya di mana? Okay.
On the other hand, Japanese apples are very beautiful. What is the difference? Japanese consumers almost place a big priority on the outer appearance of fruits and vegetables. This is the reason why the higher rate of agrochemical application in Japan. In Japan, the paddy field herbicides CNP and PCP have been widely used for about 30 years, from 1960 to 1996. These have been contaminated with dioxin, which has polluted paddy fields and rivers. However, as toxicity studies progressed year by year, dioxin concentrations were found to be negligible. Dioxin is regarded as a toxic compound which causes carcinogen, estrogen disruptor, birth abnormality, immunological damage, and brain disabilities. Professor Wakimoto Ehime University surveyed the concentrations of dioxin in the Japanese rice fields and clarified that most of the fields were polluted with dioxin at a higher danger level. The effect of dioxin are considered to be significant in the fetus. This is a picture of a disabled child born to women exposed to dioxin during the Vietnam War. Dioxin accumulates in our body fat. Unfortunately, we Japanese have accumulated high concentrations of dioxin compared with other countries. Here, I would like to summarize the problems on soils in the world: soil erosion, soil compaction, pollution of soil, water and air, global warming, gas emission, salinization, decrease of biological diversity, and biomass. excess input of energy into agriculture, shortage of plant nutrient resources, and decrease in food production and vegetation. These problems must be solved in order to develop sustainable agriculture. Today, I'm going to talk about the mechanisms and efficiency of some sustainable agriculture practices as shown in the slide. Cotton mulch and legume utilization to sustainable agriculture. In Ehime, Japan, there is one of the largest cotton factories in the world. A large amount of cotton waste, as shown in the picture, is produced every day. And it has been incinerated with fuel, leading to a large amount of CO2 emission. A huge amount of plastic mulch, 60,000 tons per year, has been used in Japanese agriculture, which is brought to landfills after use. Therefore, we developed a biodegradable mulch sheet from the cotton waste. This photo shows lettuce 15 days after transplanting. The left shows the field without cotton mulch, and the right is with cotton mulch. As you can see, without the cotton mulch, a large amount of weeds were generated, and the growth of lettuce was inhibited. On the other hand, the cotton mulch area suppressed weed beautifully. This picture shows the case of cabbage cultivation. The upper picture is without the cotton mulch. So many weeds are growing and replacing cabbage. The lower picture is with cotton mulch. As shown, the cabbage are healthily growing. The right figure demonstrates the weed biomass. The cotton mulch seed replaced weed growth 89%, as the same as plastic mulch film. We considered adding sludge, an organic waste product, to the cotton mulch to add a fertilizing effect. This figure shows maximum leaf color index of cabbage grown with several kinds of mulches. C means control without the addition of sludge. CSS 120 and CSS 180 are added with 120 gram or 180 gram of sewage sludge per square meter into the seed. It found that adding 120 or 180 grams of sludge resulted in a higher leaf color and better growth. This figure shows the fresh weight of cabbage. The addition of sewage sludge increased the cabbage yield. After harvest, the plastic mulch is collected as trash and landfilled by contractors. This is labor-intensive, costly, and environmentally hazardous. Cotton mulch, however, can be easily broken up into smaller pieces by tillage and then incorporated into the soil. Since cotton mulch is made of organic material, it can become a soil component and increase soil fertility. We discovered something interesting. This figure shows the temperature of the soil surface for 2 days of rainy and sunny weather. The black shows the surface temperature under the plastic mulch plot, and the yellow area shows that of cotton mulch plot. As you can see, the soil temperature under the cotton mulch area were lower than 26 degrees Celsius, which is ideal for lettuce growth. On the other hand, the temperature in the black vinyl mulch rose to 56.1 degree, a difference of 29.2 degrees Celsius from the cotton mulch area. It is appeared that the cotton mulch could soil temperature drastically cool, even in a hot summer. I also use this cotton mulch agricultural training in my university class to educate students about environmentally friendly agriculture. The next topic is application to paddy rice cultivation. We developed a rice direct seeding method with a cotton mulch seed which sandwiched with rice seed. As you can see, rice seeds are set between two sheets of cotton mulch. After spreading the seed on the paddy rice field, the seed germinate, emerge, and rise from the seed without herbicides. Some organic rice farmers are using it in Japan. This is a roll of the cotton mulch seed for direct seeding. The length of the seed is 100 meters. This picture shows plowing and compaction after the application of organic fertilizer to the field. If it is windy, we spread water to temporarily keep it from being blown away by the wind. The laying equipment is very simple. The direct seeding seeds were laid by attaching a laying attachment to the tractor, as shown here. 2 rows can be laid at a time. After direct seeding seeds were laid, they were immobilized with biodegradable ropes and irrigated. This picture was taken at 9 days after spreading. You can see the germination of the rice seed. After 3 weeks, rice emerged from the seed. You can see seedlings are established. After this, the farmer's only work is water management and harvesting. No herbicides are needed. It is very easy and labor saving. The left figure shows the rice yield. Unfortunately, the yield in cotton mulch plot was significantly 17% lower than that of control, the conventional transplanted plot. The right figure shows the comparison of the ripened grain rate. A 20% increase in maturity was observed and resulted in higher quality rice production in cotton mulch. The price of rice in cotton mulch is about twice of ordinary rice because of organic and good taste. Here we'd like to summarize the advantages of cotton mulch. The seed can do increase in vegetable production during hot summer with control without herbicides, improve crop quality, prevention of contamination, excess amount of fertilizer to water systems by absorption in the seed in rice cultivation, increase soil organic matter leading to improvement of soil fertility, decrease in wasting resources, energy, and cost, and reduction of CO2 emission from the incineration of the waste. The next topic is sustainable rice cultivation without fertilizers and agricultural chemicals. In Japan, Chinese milk berries has been used as a green manure in rice paddies for over 100 years. This is a leguminous nitrogen-fixing plant that reduces the use of nitrogen fertilizer. It can also supply organic matter to the soil. We tried to use other leguminous plants. This is hairy vetch, originated from America. White clover is also a leguminous plant widely used. This is a photo of our experimental paddy field before irrigation. The field was divided into white clover, hairy vetch, Chinese milk vetch, and control plot. You may feel something strange, but this is a picture of rice seedlings being planted. The seedlings are planted directly on the surface of the green manures without tilling. This picture also shows the transplanting of rice seedlings. This is clearly not the usual way. This is a picture of the establishment of rice seedlings. After irrigation, the legume cover crop died down, and only the rice grew and established. The layer of dead legumes on the soil surface prevented weed growth, so herbicide is not needed. The legume decomposes gradually and releases nutrients, and rice uptakes them. Because this field does not use pesticides and a large amount of organic matter is applied, a very large number of organisms multiply. Pests also occur, but because of the increase in spiders, frogs, and other natural enemies, there has been little damage to the rice. The rice yield is around 5 tons per hectare, at the same as the conventional of this area. This farming is lasting for over 15 years. Interestingly, in winter, a couple of parent-child swans made their habitat only in the sustainable rice field in Ehime University. This was reported in a local newspaper. A wildlife researcher presumed that they are attracted to plenty of feeds in the field, such as insects and grasses, because of the no application of agrochemicals over 15 years. This cultivation method can recover and improve the local ecological functions. I would like to conclude this presentation by introducing a Japanese word. It is mottainai. Mottainai is a word in Japanese language and has been used to say it amongst Japanese people in daily life for a long time. It means roughly, what a waste or don't waste. You know, Wangari Maathai, a Nobel Peace Prize recipient in 2004, uses this word as a slogan for environmental conservation and sustainable development with the 4 R's: reduce, reuse, recycle, and repair. Agriculture has the best platform which can utilize organic waste efficiently, enrich people's lives, and has unlimited possibilities for the future. Thank you for your attention.
Okay, that's very interesting presentation from Professor Hideto Ueno. It's sustainable agriculture can be applied using cotton mulch and cover crop as green manure. Oh, it's very good. Thank you, Professor Hideto Ueno. Okay, so we still have about 20 minutes for discussion. So I will open the discussion. If you have question, you can raise hand and then talk directly, or you can write through the chatting room. Okay, the first question is Iskandar Ishak from Print for Professor Kusmiati. Professor Kusmiati, would you respond to this question?
Okay, thank you, moderator Pak Karno. Thank you for the question from Iskandar Ishak from Brin. Okay, actually there is maybe something miscommunication. The gene from Herendong is not a salt tolerant gene, but acid tolerant gene. Yeah, it is there is not a salt tolerant gene, but acid tolerant gene. Actually, there is a breeder from Bogor Agriculture Institute. Maybe you know that Prof. Sony Suharsono. He already isolated acid tolerant gene from Herendong or melastoma, and then he also already tried to insert that gene to the soybean. Yeah, he already tried to isolate it and then inserted that acid tolerant gene from Herendong to soybean. Become a transgenic plant or transgenic soybean that has acid tolerant gene. But I think he still work on it. I think the research is still going on. I have met him maybe 4 or 5 years ago, but he explained that it is very expensive in our country to release transgenic variety. So the problem is the fund or the very expensive to release transgenic variety in our country. That's the problem that he explained to us 4 or 5 years ago when I met him. Okay, Pak Iskandar, it is answer your question, Pak Iskandar.
I hope you got the answer, Pak Iskandar. Okay, it's not on. Okay, thank you for Prof. Kusmiati to answer this. And then the second question is also for Prof. Kusmiati. Please respond to this.
Okay, thank you for the question, Novella. I think it is our student, isn't it? Okay. The background of our plant breeding program at Yardwan Pink actually is the purpose of this hybridization is to get a progeny that high of antioxidant and also sweet. So we make hybridization between purple pot. Usually purple pot has high antioxidant, but it's not sweet or it's bad, it's bitter. And then variety green pot has not has low antioxidant, but it's sweeter than purple pot. So we do a hybridization between those parents. We hope that we can get a progeny that high antioxidant and also sweet. In this breeding program, I already explained that we also do selection based on sweet taste, and also we also evaluate the antioxidant content of the progeny. And the goal of this breeding program is to get a yard long bean that is healthy for consumer. This is the goal of our breeding program, to get a yard long bean variety that is healthy. If those yard long bean has antioxidant and also the taste is sweet, I think the consumer will be like this kind of our yard long bean variety. I think it's answer your question, Novella. I hope you can join with our research, Novella. Okay.
Yeah, I think it's already answered, Novella. Thank you for the question. The next question, Okitalita Widaryati Undip for Professor Hideto Ueno. Professor Hideto Ueno, would you respond to this question?
Okay, thank you. Widaryati. Yes. Unfortunately, organic farming in Japan is only 0.5% of Japanese agricultural area. Only 0.5%. But
0.5 organic farming.
yeah, 0.5% of area. But Japanese government, Japan's Ministry of Agriculture, Forestry, and Fisheries has set a goal of increasing organic farming to 25% by 2050. Yes, so now Japanese government enhancing to expand organic farming in Japan. Okay.
Okay, yeah. So Widaryati, there is organic farming in Japan, and the target for the Japanese government is to achieve about 25% of organic farming by 2050. Is that right? Yeah.
Yes.
Yeah. So there is access. Okay, Widaryati, does that answer your question? Yeah, I think so. So the next question, Raja Samudra for Prof. Kusmiati.
Okay,
Please
thank you for
respond to
the
this.
question from Raja. Yeah. From Raja Samudra. Okay. I want to ask about your research for soybean wood. Okay. Actually, the goal of this breeding program is to get soybean that tolerant at saline soil. So we do selection at saline soil, but in the progress of this research, we have to change. We use what you call it, alternate breeding. So, for example, at the first filia and the first generation, we call it M1. We do the research in Rembang Regency or at saline soil, and then the second generation we select. Or we do research in the non-saline soil, because if we select all the generation at the saline soil, we are afraid that we can lose the genetic resources or the seed, the soybean seed. So we do alternate breeding program from the saline soil, and then the next generation in non-saline soil, and then the next generation at saline soil again. Like that, we do alternate breeding program for the selection. The goal is to get a soybean that is tolerant at saline soil. That is the goal or the purpose of this research. Actually, of course, tolerant at saline soil, but not reduce the production. This is our goal. Okay, Raja Samudra.
Yeah.
Is this okay, Raja Samudra?
Yeah,
My answer is like that. Okay, thank you,
Yeah.
moderator.
Okay, Raja Samudra, I think you can join to this project in the future. Okay, the next question is from Ratnawati from Unit 3 for Prof. Hideto Ueno. Prof. Hideto, would you
yes.
respond to this question?
Yes, thank you, Latona. What is the point about organic farming in Japan? I think the techniques in Japan is applicable in Indonesia. So because main product is rice and vegetables, and it's famous in Japan. And weather condition is that's the same. So I'm think organic farming technique in Japan is applicable in Indonesia. Okay.
Yeah, I think so. The organic farming is universal, so it is applicable in any country. But the interesting is using the cotton seed, the cotton waste. It's very interesting. We don't have that seed. Okay, the next question is from Gilman Ainuddin from Undip for Prof. Ueno. Would you like to respond to this question, Prof. Hideto Ueno?
Yeah, thank you, Gilman. Yes, actually, cotton mulch seed is already available in Japan, Japanese market. A company of cotton mulch producer are selling to organic farmers in Japan, but unfortunately, it is not used by the many organic farmers. Some farmers, I think around 100 farmers are using of cotton mulch for rice cultivation, organic cultivation, and they are learning about the latest techniques for using cotton mulch to improve their techniques. Okay.
Okay, thank you, Prof. Ueno. Yeah, the cotton seed is very interesting, and that I think the new thing for us in Indonesia. And Gilman asking that we don't use much in paddy rice in Indonesia. Yeah, maybe next time we can use something like that. Okay, thank you.
Welcome.
Okay, the next question. We still have 3 minutes left. The next question is from Oki Talita from UNS. Is this for Prof. Kosmiati or Prof. Ueno? Okay, maybe this is for Prof. Kusmiati.
Okay, thank you, Oki Talita from Universitas Negeri 11 Maret. Okay, in my presentation, so that Sesbandia grandiflora and Panicum maximum can be classified as a moderate saline tolerant. The what you call it, the mechanism